Okay, so what we're going to do today, guys, is we're going to, and girls, if there are any girls out there, I have to remember that now. So we're going to just introduce you to the organic functional groups. Okay? So if you want to write this down as we go, you can, but I will leave everything on the board. Alright, now, the thing we've done so far only is this. We've actually done alkanes, and we did alkenes, and we've done alkynes. That's the only groups that we've talked about so far, but there are many, many more. I'm only picking on a few. We're only going to do these 4 at year 11. When you get to year 12, there's about another 4 on top of that, another 4 functional groups. So I'll cut it down to try and make it simple. Okay? So you need to be able to recognise these groups. So if I gave you some molecule that you haven't seen, you should be able to pick out all of these functional groups. We're not going to do too much in relation to how we make the functional groups at stage 1, unfortunately, because we're going to run out of time, but you should be able to identify them. Functional means they react in a certain way. So if I've got an alcohol functional group, I'm looking for just an OH next to a carbon. So that would be called an alcohol functional group. If I was looking for an aldehyde functional group, I've got a C-double-bond-O next to a hydrogen. These are always going to be on the end of the carbon chain. They're called terminal functional groups because they can't be anywhere else. Carboxylic acids, well, we've heard of acids and bases before, and we did do carboxylic acids, but you did not when we were doing acids and bases. This is CO2H. So you might see them written like this. It could be written as RCOOH or RCO2H, depending on whether we're looking at condensed or structural. So this is a functional group as well, and there's a whole series of functional groups called carboxylic acids. And who's heard of fatty acids? Fatty acids, yeah. So you might know it in biology. So the fatty acids are where the carbon chain is a really long carbon. Oh, I forgot to explain what R was. R is just another carbon chain. Okay, so we use that symbol in organic chemistry all the time. So R is just a carbon. Could be anything. And the last functional group is called esters. We're going to make an ester in a few weeks' time, actually less than that, a week or so. And the reason we're going to make an ester is because they smell nice. And because esters are made up of alcohols and carboxylic acids. And when we look at esters, before we do the practical, we're going to do esters in a bit more detail. So basically these are connected. In other words, if I were to break that apart, then this and this come from 2 different functional groups. The alcohol would have been this one for the ester, and the carboxylic acid would have been that one to form the ester. But I don't want to get too much into how esters are made right now. We just want to look at how do I pick the functional groups and how do I name them. Okay? Questions so far? Everyone cool? Alright. So I could give you some weird molecule, and I will. I'll just invent a molecule right now, and on this molecule I'll put some groups, and we'll see if you can identify, alright, some of the groups that I'm going to put onto the molecule. So we will just draw it. Oops, I need an O and a H there. And then I'm going to go like that. O. Okay, so there's the molecule that I've just made up. It could be some wonder drug for curing some horrible disease, but that's a organic molecule, and it's in its structural or skeletal format, I should say. So anyone might have to go up where the functional groups are in there. Rocco.
The carbox or whatever that is on the left, very far left.
This one? Yes, good, very good. Okay, so here I've got a carboxylic acid functional group. Okay, what else have I got in there somewhere?
An alcohol.
Where's the alcohol?
The OH.
This one?
Yeah.
Yep, good. So I've got an alcohol functional group in there. What else have I got? Anyone else? Anything else you can pick up in that molecule? Sorry. Where's the aldehyde? Chris? Up the top up here? No, sorry. Down here? No. It is. Noah's pointing over there, and it is. There's the aldehyde. I haven't shown the hydrogens because it's a skeletal structure, but there is a hydrogen sticking out of there. So that's an aldehyde functional group there.
So is the bottom.
This one here?
Yes.
That's not a functional group that we did. I put it in just to trick you. It's called a ketone functional group, but we haven't done it. Alright? But it's not one of the groups we just did. The only other one left is this one up here. Must be. No. Okay, this one here up here is the ester functional group. Okay? This is the first molecule you've ever done like this. However, you have to be able to get used to picking out functional groups within a molecule, because they determine how the molecule is going to react. And in stage 2, we're going to learn all of these structural formula, or all these functional groups, and how to make them, how to test for them. Alright, so if I said how do you make that molecule, you would know how to make that molecule next year in year 12. Starting from some simple molecule, you would know how to build that up. End theory. Okay, naming. All we're going to focus on today really is naming, but I've gone off on a bit of a tangent there. Alcohols. So if I have an alcohol, for example, like this, and I've got rid of just the hydrogens, it's sort of similar to the way that we named alkenes, alkenes, and alkynes. So we look at the functional group. So the first thing is, when you are naming it, you have to pick out the functional group. It's an alcohol functional group. So this would be called 1, 2, 3, 4. We would name this butane 1-ol. Butane because it comes from butane, and 1 because on number 1 there is an ol, and ol is short for alcohol. Okay? You can also name it like this: 1-hydroxy butane, but we prefer to use the top one, butane 1-ol. Now, for those that are thinking, we also had things like butene, didn't we? So butane 1N 1-ol could exist, couldn't it? So we can now combine ens and ines and ols all together. Alright, it gets fairly complex, but the language hopefully is understandable. Alcohols are named with an ol. Okay, aldehydes. I'll use the same one for aldehydes. The same number of carbons. 1, 2, 3, 4 if it's there. Okay, on carbon number 1, it can't be anywhere else. That would be called, that would be called butan Al. So Al, perhaps we shut the door, please. So butanal is, Al is how we name aldehydes. But we never have to have butane 1-al. Why not? Why don't we have butane 1-al? Patch? Why don't we have butane 1-al? Okay. Rocker?
Because it can only be at the end.
It can only be at the end. Because if I do this, if I redraw that molecule like that, and if I put it there, it's not an aldehyde anymore. It's actually just turned into another functional group called a ketone. And we haven't done ketones yet. Alright? So, butanal is how we name aldehydes. Alright? Next one is carboxylic acids. I'll do a carboxylic acid with 4 carbons. There it is there. Carboxylic acids are the same because they're always going to be on the end, okay, of a chain generally. So we count the carbons. 1, 2, 3, 4. So this is called butanoic. So it's an oic acid is how we name carboxylic acids. Alright. Again, another name you've got to learn. So we've got, so far we've got anes, enes, ines, now we're adding ols, als, and oic acids. Depending on what the functional group is. Alright. The last one is an ester. Now, I'll do the ester with 4 carbons. 1, 2, 3, 4. That's one part of the ester. And I'll also do it with 4 carbons on the other side of the ester. Now, esters are complex because they're made up of 2 halves. The half would be this. 1, 2, 3, 4. That would have been how this ester is made. And this, which we've got already on the board, would have been the acid that it came from. So when you're naming an ester, it's best to split it into the C-double-bond-O becomes the carboxylic acid half of the molecule. That is butanoic acid. And this is the alcohol half. So this is butanol, which we've got up there. Okay? Oh, and again, if I haven't got a number 1 in, it assumes that it's on carbon number 1. So this ester is made up of butanol and butanoic acid. Okay, you ready for this one? Almost. So this one here is called, the alcohol goes first, followed by the acid second is how we name an ester. So this one here is called butol because it comes from butanol. Butol, butan, butol, butan, O, H. So, when we're naming esters, really complex, we split the ester into the alcohol and the carboxylic acid. I prefer to draw each of them, so I've got them named. It's come from butanol and butanoic acid. And then when I name it, the alcohol goes first. Here's my alcohol. That's the butyl part of it. And the second part is the carboxylic acid, butanoic, it would have been, so it turns into butanoate. So it goes like that and like that. So the oil from the alcohol and the OA from the carboxylic acid. Okay, we're not going to complicate things yet. So all we need to do to get out of today's lesson is, how do I identify alcohols? How do I get aldehydes? How do I get carboxylic acids and esters? Can I pick out the functional group from some weird molecule that a teacher writes in the book? Okay? I'm not going to ask you to name that molecule yet. Okay? And I wouldn't anyway. And then how we name them. Okay? So how do we name alcohols? With an ol, or with a hydroxy. How do we name aldehydes? With an al. How do we name carboxylic acids? With an oic acid. How do we name esters? With the alcohol first, carboxylic acid second. But the only 4 functional groups we're going to focus on, alright, for year 11. Alright, any questions? It's pretty detailed, isn't it? Alright, so hopefully that will help you get out the road to identify most of those structures. Okay, let's move forward to the next part.